Hello. Yes, we welcome you back to PSSB. It's me, Richard. Today we are going to look at this question. It comes from Electrostatics. Let us analyze it. It says that consider three identical metal spheres, Q1, Q2, and Q3, each of value plus 5.6 nanocoulomb, placed as shown in the vacuum, as shown below in the vacuum. Is that okay? So now we come here, we say draw force diagram showing all the electrostatic forces acting on Q1 due to Q2 and what? Q3. How do we go about that? Okay, this is what you have to remember. You have to remember that this is the charge we are talking about. It's positive. So here we have positive. We have positive here and positive there. Okay. And we are finding net force. We are finding the force acting on this one. Okay. So what do we do? Let us look at, first of all, this force, Q3, how it influences this one. So now you ask yourself a question. What will Q3 do to Q1? We have to remember that in all cases, it is Q1 which will move. It is the charge whose net you are calculating or whose net you are finding which will move. So what will Q3 do to Q1? It will repel it where? Downwards. Okay, we can call that one F1. Okay, and what will Q2 do to Q1? It will repel it to the left. And we can call that one F2. So now we have now these two forces and they're acting at 90 degrees. Okay. Then next. Okay. Then comes this question. It says, calculate the net electrostatic force exerted on Q1 due to Q3 and Q2. Okay, what do we do here? We say the force Q3 exerts on Q1. Let's look at that. Okay, this is what we get out of it. So it's we have called it F1, and when you apply Coulomb's law and you substitute, what you get out of that will be the force Q3 exerts on Q1. Let's see what we get. Okay, so we have found it as this 0.0001764 newtons. What is next? Then next is going to be the force Q2 exerts on Q1. Let's get that one. So we get it having the same magnitude as that for F1. Then you have to recall, what do you have to recall? That What we have here are the directions of F2 and F1. So they are acting at right angle to each other. So what do? You apply Pythagoras to get the net force. Let's do that. So this is what we get after substitution. What is the next step? Is to find the square root of that, which is 0.000176 squared plus 0.000176 squared. And what you get out of that will be the F net. Let's try to get it and you see what we have. Okay, so this is what we get after substitution and after finding the square root. So it's going to be 0.00249 newtons. That happens to be our net force. Then comes the next question. It says, calculate the net electric field at Q1 here due to Q2 and Q3. So if you have a charge here where you say the charge and you are calculating the electric field at that point, it means that this charge has lost the influence. So in other words, what we are going to do, we are going to calculate the electric field at Q1 at this point where Q1 is due to Q2. And we are going to calculate electric field at this point due to Q3. And that's what we are going to put. Let's start with electric field at Q1 due to Q3. Okay, so this is what we get. That's what we get after substitution. What you have here is electric field at Q1 due to Q3. And it is 31,500. Okay, now what do you have to know? You have to know the direction. You have to remember that if you are determining electric field, this point is positive. And where does it go? It will go down. So it does indicate it here. Okay. Next, we look at electric field at Q1 due to Q2. Let's look at that. And this is what we get after substitution. For the direction, remember we have this point as a positive charge and it is going to be repelled to the left. So this is going to be the direction. So what do? We put these two electric fields together. And this is what we know. We know one is moving downwards. We can call that one E1. And we know one is moving to the left. We can call that one E2. Now with those two, what do we know? We know that our E net is here. Okay. So when you look at this, what do we know? We have to remember that these two are meeting at right angle. So we go Pythagoras, saying E net squared is equal to E1 squared plus E2 squared. Okay, we are looking for E net. So what is E1? is that, and it's going to be the same as for E2. And what are we going to have here? If this is our innate, so the square root of that will be the answer. So we're going to have 31,500 squared plus the same, and what we get is going to be our innate. So this is what we get after substitution. So our net electric field at point Q1 is this. Okay, it's 44,544.73 Newton per coulomb. So with that, we are going to cut this video here. We appreciate your time. We would urge you to click the like button, and if you have not yet subscribed, we urge you to do so. See you next time. The channel is PSSB, Physical Sciences Silver Bullet, and it's me, Richard. See you then. Bye bye.